Hello, I'm Pete Schellenbach from Zumasys. I'm the Director of Product Development, and we're going to do a deep dive into dictionaries. And we're not talking about the Webster's Dictionary, we're talking about data dictionaries for the PICK Multivalue database. So just to review a little bit, the PICK data model, this was presented in some of the other Multivalue videos, specifically the PICK file system by Patrick, video number 4. The PICK data model starts with an account, which is an analogy to a database in one of the relational style database systems. Basically, it's just a collection of files, which is the next level down. We have files, which are part of an account and are the equivalent to tables in a relational system. And the file really has two sections. As a dictionary section that describes the data, and as a data section, or more than one data section, which contains the data. All of these, the account, the dictionary, the data files, they have an identical file structure. They're just a file that has records. There's nothing special about these files, except for that they have a use that makes them special. So the voc, or the MD, is the account, and that it basically gives you the vocabulary and the list of files that are contained in your database. The dictionary, it describes data for a file. It doesn't have to be dictionary data, it can be any data, but we want to use it with the dictionary data, and data is data. This is kind of analogous to a nested folder structure, where we have an account folder, and then with that we have a dictionary folder, and within that we have a data folder. Dictionaries are to the multi-value file system what schemas are to relational databases. But there's a really big difference here. The dictionary is a descriptive model and a schema is proscriptive. That means the dictionary says what it should be and the schema says what it must be. So dictionaries are using the dictionary model. It's very flexible, but you can also put junk in places where you would be disallowed in a relational system. On to dictionaries. So as we said, dictionaries are just files, and files hold records. So the records that we normally put in our dictionary would define our data. And there's a code on the first line of the dictionary records. Typically we find for data definition, the code is A or S or D. For a computed field, the code is usually I or V, but we could also have A or S have a computed field, and we'll talk about those in a little bit. Some systems support all of these, some only support A and S, and we'll talk about which systems are which. Other things you could have in a dictionary are phrases, which are like collections of other words. And you can use file pointers on some machines, and you can put pretty much any arbitrary data there that you want, although I don't recommend putting lots of crap into your dictionaries. Other things you might have there are structural data, things that would count items or give file sizes or count values. Those are not actually data that you have in your database, but they're metadata about the database. Dictionaries can be reused on multiple files. For example, it's common in a PICK application to have a single dictionary that then has several data sections. For example, customers might have customers as its main data section, and archive for archive customers, and perhaps prospects for prospect customers, but they all share one common dictionary. It is also possible to use multiple dictionaries with a single data file. And that is done with the using clause in the query language. This is probably a underused feature. It's really powerful because it allows you to do things like prototyping and testing without changing the main dictionary on a file and build alternatives, or maybe just for alternative views of a data file. And I do have an example of that. So here I'm going to sort a file called invoice, but I'm going to not use its normal dictionary. I'm going to use a dictionary called invoice-pi. And then I have some criteria called looking for quantity more than 10. You can see it just acts like it was a normal dictionary. In fact, it is. It's just a different dictionary than would have normally been associated with that file. So why do we use dictionaries? Dictionaries help us describe our data. They help us define our file layouts, which is really important when we're building applications so that we understand what things are in what fields. And as we add new fields, we have a place to refer to that tells us where the next one is. If we're consistent in how we use our dictionaries and we actually use them to create a clean file layout, we can use tools to convert those into, say, include items that you might use into a basic program so that you get common nomenclature all through your application, both in the query language and in basic programs. So they're really powerful. They're very flexible. The data definition records in a dictionary are the A, S, and D types. And because of that flexibility, we have to be very careful and have some kind of convention or policy that allows us to use them to describe our file layout without polluting our dictionary with other things and making it difficult to actually understand the file layout. I have a small example of showing the file layout. Okay, so I have a phrase in my MD called layout, which just shows the fields that are used mainly for describing what is actually in a file. And if I list this dictionary for my invoice file, and I assume that all of my A types are the real dictionary records, and ask for the layout, which if I type it right, it will show me what, you can see in order of attribute number, what is used in each of the attributes in this file. So if I need to find where I can add a new attribute, I can look at this and it'll tell me what the next space is. Or if I'm curious what's in, say, attribute 3, I can look at this and I know what's in there because my dictionary is well defined. One of the important uses of file dictionaries is in the query language. They're used for specifying the fields that you want to select and also for fields that you might want to output. And it's not just for queries, but also for creating reports, and they're useful for exporting data. For example, in jBASE, there's a jExport command, which is part of the query processor and outputs the exported data in a CSV format. QM has a toCSV option that allows you to export the query output as a CSV file, and other systems have similar things, so it's not strictly for querying and reporting. So their dictionary can be very useful there. The thing that we have to be really careful with is that it's easy to pollute your dictionary with things that make it really difficult to use. If you look at a system that's been used for a long time, decades maybe, and look at a dictionary that's been built up over time, you might find in there hundreds or even thousands of definitions, and most of them are not useful. Most of them don't actually tell you what is in the database. So you have to be very careful to use good standards. For example, always using the A type to define a field and the S type for any alternate views of that field. And if you're very careful with that, then the dictionary becomes a really good tool, and you can avoid this pollution that occurs over time, which makes it very difficult to use a dictionary. When dictionaries get that polluted, developers seem to resort to other tools, maybe actually putting their data definitions into a completely different file, and ignore dictionaries completely because they've become useless. So it's not a good idea to do that. Keep your dictionaries unpolluted. So the multi-value database has basically two roots, PICK, which was Dick Pick and Don Nelson, and Prime Information, which is a separate implementation. The two versions actually created two different dictionary styles, and the table here shows what the two styles look like and shows what's in each of the fields. They both do the same thing, but they're arranged differently. They have a different file layout, and some things are combined in one and not in the other. So you can always go from one to the other just translating. It's pretty simple, but they are different, and we'll be talking about some of the differences after this. One of the big differences between the PICK version of dictionaries and the prime information version is the computed fields. The prime information version uses either I or V type fields and has an expression in those fields that is similar to BASIC, but not as robust as BASIC. Sometimes these are actually compiled, and there's a compile command that you need to run after you change your expressions in these I and V fields. For PICK style dictionaries, there are A expressions, which stands for algebraic, which allow you to do computed results. Those can be used in the S and A type definitions. And then we can't leave out F correlatives. I know that any of you who's listened to some of Paul's multi-value talks, he always talks about F correlatives. F correlatives are another computed field structure. They're basically a reverse Polish notation function, and they were the precursor to the algebraic expressions, the A types. When you write an A type and use it, it actually compiles down into an F type when it runs, so it doesn't really matter. You don't need to use F types. They're really hard to understand, and they're much harder to read, but they do exist, so I just had to mention them. Finally, all of the PICK or prime information style dictionaries can use a basic subroutine, call to do the computation in the field. Basically, you pass in the current values and the current record, and the subroutine cranks away at whatever it wants to and returns the answer for that field. So those are kind of the different ways of doing computed fields in the two flavors. Other differences between prime and PICK are the fact that the PICK version of dictionaries has the width, justification, and masking as separate fields in the dictionary record. The prime information version combines the width, justification, and masking in the format field. And the prime information version doesn't have an equivalent of the synonym that we have in PICK, the S code. And I think that it's useful to use some kind of differentiation in your dictionaries between real data, which is easy to spot if you use the A only for real data fields, and synonyms or different views of the data, then you can use the S code for those. If you're using only prime information style dictionaries that use D for all the definitions, then you have to come up with some other convention, possibly using the description that's optional after the D in the first line to differentiate between the views and the actual real data definition. Here's an example showing the difference between the computed field for an invoice total using the PICK version first, and then the prime information style. You can see that in the PICK version, the computation is done with an A code on line 8. And in the prime information version, the same calculation is done with an I expression on line 2. Both things compute the same value and return the same result, but they're just formatted differently and use slightly different syntax. Conversions and correlatives. These are like really important and can be really confusing, and they're very powerful. Really, really useful in the PICK dictionary structures. So basically, these are procedures or processes that convert data from one format to another. They might be doing computed fields, or they might be converting internal data in a format. For example, a date internally is usually a number versus externally it's a date you can read, or doing decimal scaling for financial values. So they're really important parts of a dictionary definition. In the PICK style, we have something called correlatives, which are on line 8 in the dictionary, and then there are conversions on line 7. They're both the same kind of codes. The difference, the main difference is that correlatives run first and then conversions happen second, and correlatives are processed during the selection and sorting phase of a query, and conversions are processed during the output, almost. We'll talk about the exception. The correlatives that do computations or actually change what the data is are similar in to the I type of the PI style dictionaries, where you can take a function and use that to actually alter the data. Conversions are usually processing some kind of raw data and converting it into a format that's nice to read. For example, putting commas in a decimal number in the thousands positions, or converting an internal date, which is usually just a number, into a string you can read. Certain conversions actually are used in the processing of the query statement, where a value that you are using for selection criteria, for example, a date like date greater than January 1st, are converted into an internal number and then used in the selection and the sorting process, and then again converted back as a printable number on output. I do have an example of that. So here is the definition of a date in our sample invoice file, which shows that the date conversion is on line 7. It's a D4 for a 4-digit year and a date. The interesting thing here is that I can use this as an input conversion when I'm typing in a statement. So here my input statement asked for a date less than 1/1/2000, where 1/1/2000 is just a textual string, but the dictionary conversion on line 7 basically took that and converted it into an internal number, and then when the system is processing the query, it's comparing that number with the number that's stored in the file. I'll now show the actual file data here, which I know is on field 1 because of the dictionary definition we looked at just before. If you have multiple conversions on either line 7 or 8 or on line 3 in the PI system, you can separate those with value marks, and then they're applied in order. So the first conversion runs, and then the output of that is fed into the second conversion, etc. So these things can be really powerful for processing the data in your reporting or output to other formats or queries. So final thoughts here. 2 other topics. One is the default display fields. If you type in a query and you ask for no specific fields to be displayed, there's a way to specify the default fields in the dictionary itself. There's a phrase called @ just the @ sign, which you can see on the screen here. In this case, the default for this invoice file is customer number, UPC, description, quantity, and amount. So something you might actually see in an invoice. So if I asked for records from the invoice file and I didn't say what I wanted to see, this is what I get to see. If I was to direct my output to a printer instead of to the screen, you can use an alternate phrase called @LPTR. I don't really have an example of that because I'm not printing anything, but some files will do that, and it's usually done because the printer output is usually wider than the screen, so you might add more output to the display when you're going to a printer than on the screen. Then finally, there's a really archaic way of doing default output, and it's using numbered dictionary items. I don't recommend doing that because the numbers are often confused with attribute numbers. They're a little bit fragile because if you miss one, It stops the display at the one that you've missed. It's difficult to insert one. If you change your layout, it just becomes a problem. But they are available. They do work. For an example, I have here in the which file is this? Customer file? No, I have a demo file called demo file. And the default output for this file is based on these numbered dictionary items. Just going to show you the first three here. And basically they're just a duplicate of the first three attribute definitions for the file 1, 2, and 3. They happen to line up with the actual attributes 1, 2, and 3, but that's just because they do. They don't have to, and that actually is a source of a lot of confusion. So I recommend using the at phrases if you're going to have default outputs. And finally, associated multi-values. One of the most useful features in the multi-value database is the ability to put multiple values in a field. Often though, you'll have sets of multi-values. You'll have several fields that all are related together and each have corresponding values. So for example, on an invoice, you might have a product number field, and that's associated with a quantity field, and that's associated with a price field. And so that is a set of multi-values. And it's important to group those together so that association isn't lost. And that's what we're trying to do with associated multi-values. In the PICK dictionary model with the A and S codes, the association is handled by putting a controlling list of attributes in the primary field and a dependent list in the secondary fields. It's a little convoluted and a little fragile, but it does work. It does help you associate them, but it's all done by attribute number and not by field name, so it can be a little bit difficult to manage. That's done on line 4 in the dictionary. The primary field has a C and then a list of the numbers of the dependent fields, and the dependents have a D and then point back to the primary field. In the PI dictionary system, the association is on line 7 of the dictionary, and it basically is just the name of a phrase that's in the dictionary, where the phrase is a list of the attributes that are associated together. So it really makes a lot of sense. It's much easier to maintain, but that is only available on the D and the I type dictionary items, not with the A and the S. As far as I can tell, the main reason you need to use these in the query processor is for the by exploding sort feature, which basically explodes the multi-values and sorts as if they were exploded into single records. That way the multi-value sets all remain related together. I can't really find any other real purpose for them, for this association, except for documentation, which is really important, so that you know in your file system what is associated with what. So we've just gone over everything I know about dictionaries, and I hope that you learned something useful there. Keep your dictionaries clean, avoid dictionary pollution, and I think that you can find them very useful in documenting your multi-value database. I'm Pete Schellenbach for Zumasys, and thanks for watching.